Hi guys and welcome back to Spring School Matrix. I hope that you are having such an awesome time. I think Marara and I and Tamlin are having an awesome one, right?
Great time.
We were just discussing this prize that we're giving away. See, we've got these 3 CDs, but in this Platinum Edition, which is Mikasa, there are 2 CDs, so that's 2. Let's see how everyone's maths is. DJ What, he's only 1 CD, but still. And then we've got this Electro Candy, which is given to us by Soul Candy, but this is 3 CDs.
That's
So
like
yeah.
3, 2, 6 CDs.
6 CDs, right? And a T-shirt and a book, and yeah, it's
Guys,
pretty awesome.
you have to enter. I mean, really, 6 CDs.
Yeah, no, guys, and also I just wanted to say that we have reached 19,000 thanks to you guys. We think that you guys rock, and we think that you guys are absolutely awesome. Big up to you guys watching, Sidonia, Kashifa, Anissa, Noxpedia. So glad that you are tuning in, and I think we're going to take a little less time away from Tamlin's teaching, and we're going to pass it back to her. But guys, if you do have any questions, please post them onto the page. This is the time to ask questions. There is no such thing as a silly question, only the question asked after the exam, because then what?
No time.
Then it's too late. Then it is too late.
Too late.
Chat to us on facebook.com/learnextra, also on Twitter @learnextra. And now let's get on with the show. Tamlin, take it away.
Right, guys, let's have a look at some more identities. If you were watching a little bit earlier, we did quite a show on identities, where we practiced quite a few of them. So if you had watched that, I'm sure by now you're feeling pretty comfortable with them. But let's have a look at more of them. These, once again, are a sure thing in your exam. You will definitely get them, all right? The example that we're going to have a look at over here, just to point out to you, does not involve double and compound angles or double angles at this stage. So this would be sort of a more what you learned in grade 11 in terms of your reduction formula, and just how we use that reduction formula to prove a left-hand side equals a right-hand side. Please remember, if you are solving or if you are proving an identity, that's what your goal is. Please, you are proving that the left-hand side of your equation is equal to the right-hand side. You are treating them as 2 separate entities. You do not cross anything over the equal sign. That is really important to remember. Okay, so let's have a look and see what we've got.
Tamlin?
Yes.
Before we go on, can I ask you a quick question from Nombulelelo? And
Yes.
I think it's got to do with what we're talking about.
Pythagoras question.
Pythagoras question. So she wants to know, for the Pythagoras question, would she be penalized for using the sine rule? Because she got the same answer.
If she got the same answer, what I would say is this. If you got the same answer, that's great. The question I would have to ask with regards to that is how she got the answer if you had the angle of alpha, because you would need to know what that angle was. So what I would say to you is just, if you sometimes can apply the sine rule, and that's fine, watch your mark allocation. If the sum is only for 2 marks and you've kind of gone around and done this whole long sine rule, it's also a case of wasting a little bit of time, which you always just have to be careful of. With that question, you didn't know the size, you only knew the 90-degree angle, you didn't know what alpha was. So that would make me question how we got there without knowing what alpha was. So I'll go and have a look at it. I'm more than happy to go and double check and see. But to answer the question, can you use the sine rule? If enough information is there and it's applicable, you can. But with a 90-degree triangle, you've got your opposite, your adjacent, your hypotenuse, and as a result, you can use your normal trig functions or trig ratios. So as a result, it just causes you to not waste any time.
It's simpler also.
It is simpler. Yeah, that's it. Okay.
Thank
So
you,
I hope that answers
Tamlin.
your question.
Hope that answers your question.
Yeah.
Okay. Let's have a look at this example over here where we are proving our left-hand side equal to our right-hand side. Okay. I have got sine of 90 plus x. I've got that multiplied by cos of x times by tan of negative x. Okay, so here's something to watch out for over here. We're going to just make a little mental note that we're going to have to be careful there. We are going to have to be careful over here as well. And, okay, we're also going to have to watch out for this, but in fact, we're not going to, well, it's just normal reduction formula there. We're not going to have to be quite as careful with that one. Let's see what we've got. Sine of 90 plus x. I really hope by now that the teachers have drummed it into you guys enough that if you are working with a 90 plus or a 90 minus, you are changing to your co-functions, okay? And that simply means that your ratio of sine theta is equal to cos of 90 minus theta, and vice versa. Okay, so if I've got 90 plus x, first things first, that's taking us into quadrant 2. Okay, now here's something you've got to watch out for. In quadrant 2, sine is positive. Okay, so we know sine is positive in quadrant 2, but here's the tricky thing. Because of the 90, sine changes to cos. Now this is where I know learners have a problem, because suddenly everybody says, hang on, in quadrant 2, cos is negative. So now, is it positive or is it negative? Marara, do you ever have that problem?
Yes, I do.
Okay, it always takes the sign of what it was originally. Okay, so if sine is positive, even though the cofunction changes it to cos, it stays positive. Okay, so it's going to stay positive and it's going to change to cos x. Okay, we have then got cos x, which nothing's going to actually happen to that over there. Right, now we're sitting with tan of negative x, okay? Right, Marara, tell me, if we're working with a negative x, do you remember which quadrant we're in?
We're in the fourth quadrant.
Excellent, we're in the fourth quadrant, okay. So anytime we see that I'm working with a negative angle, we know that we are working in quadrant 4, okay? Which means that in quadrant 4, tan is negative, okay? So we have got a negative tan x. Right, and this is all over. I've got cos of 180 plus. If I look at my axis, 180 plus is in my third quadrant. And if we remember our cast diagram, the good old cast diagram, in our third quadrant, cos is negative. Okay, so that's going to also be a negative cos x. Okay, so what we've got on this left-hand side so far is cos x times by another cos x times by negative tan, and it's over negative cos x. Okay. This is one nice thing to spot with an identity such as this. Everything is being multiplied. And as long as there is a times between each one of your terms, you can cancel. Okay, there's no problem with that. As soon as there's a problem is where there's a plus or a minus separating your terms. And that's where you've always got to be very careful. Over here, we don't have to worry about that. We have everything being multiplied. So we can go ahead and cancel our cos x with our cos x, and in fact a negative over a negative will become positive. So those two have fallen away as well. That's now left me with a cos x multiplied by tan x. Now tan, when we're working with an identity, a worthwhile thing to do is always to change everything in terms of sine and cos. Why? Because then obviously you're working with like. Okay, everything is in the same thing. So I've got tan x, which I'm going to change to sine x over cos x. Okay. And with that, we can cancel top with bottom there, and we are left with sine x. Now let's just take one quick look at what we were supposed to prove, and we can see that we have done it. We have managed to prove that your left-hand side, all of that worked its way down to being just sine x, which is exactly what it was on the right-hand side. So please make sure you finish off with your statement that therefore your left-hand side is equal to your right-hand side. Okay. What's really nice about those trig identities is when you're proving them, you always know when you're right. So that's always a nice thing to know. When you've got it, and that's always a nice feeling. Okay. Right, what we're going to have a look at now is just a bit of interpretation on our trig graphs. Okay. What we have been given in this question, grade 12s, is we're given a trig graph, and we've been told that it represents the function of f of x, which is equal to sine 3x. Okay. Please remember, if there is a number in front of your x or your theta, whatever that angle is, that represents the period of your graph. Okay, now what our period is how many repetitions of our graph do we have between 0 and 360. Okay, your normal period of a sine graph is always 360. Putting that 3 in front of it is saying that from 0 to 360, we are now going to have 3 repetitions of it. And as a result, what's happening is that your graph becomes squashed. Okay, everything happens earlier and sooner, and it happens more often. Okay. So just to quickly give you a bit of background here, if the question said, and in fact I think that is exactly what the first question says, the period of f. All right, here is a fairly common mistake some people make. They say the period of f is 3, okay? And the reason you say that is because there's a 3 in front of that x over there. The period is how many degrees it takes to complete a full repetition of your graph, okay? So unfortunately, it is not 3, okay? If you had to think about a sine graph squashed into 3 degrees, that would be extremely small. So that's not what we're talking about. How many degrees does it take? So our normal period is 360 degrees of a sine graph. And what we do is we divide that 360 by the 3 repetitions that we would have, resulting in 120 degrees. That is then the period of your graph, okay? If I were to quickly have a look at it, if I've got 120, which is over here, okay, my normal, this over here is 1 full repetition of your sine graph, and it went from 0 to 120. So you can see that that was your period. That's how many degrees it took to complete 1 repetition. Okay. All right, so that would be the answer to F. The period is equal to 120 degrees. Okay. From there, they've now said to us that we are going to write down the solutions for sine of 3x. Okay, that's the graph that we've got, where it's equal to -1 on the interval from -90 to 180. -90 is our lowest value on our x-axis, up to +180, which is our highest value on our x-axis. Okay, so they're asking us, where is the function sine of 3x equal to -1? Okay, what I want you to do is this. Take yourself a line, and I want you to draw it through the y-axis at -1. Okay, we can move that up slightly. There we go. Right. So where is it crossing the graph at the point where y is equal to -1? We have a point of intersection over there as well as over here. So where x is equal to -30, y is equal to -1. And where x was equal to +90, x was equal to, y was equal to -1. Okay, so the way we write our answer is we say x is an element. Okay, we're going to use our curly brackets like so, because what we're doing is we're not talking about a range of points. I'm talking about specific points. Okay, if I wanted to talk about a range of points from one point to another, we would use our interval notation, which is our square brackets and our round brackets. Okay, I'm not doing that here. I'm saying that I'm specifically talking about -30, and I'm specifically talking about 0.90. So therefore, in a curly bracket, we say that x is equal to -30 and 90. And we close that off. Okay, so again, don't fill those in with square or round brackets, because then what you are saying is that it's everything on the x-axis from -30 to 90, which obviously is not the case there. Okay, right, that's that. Let's have a look at the next part of it. Okay, they're now saying to us, give the maximum value of h. Now, h is a new graph. We don't have this yet. Where f of x is, where h of x represents f of x minus 1. Okay. Grade 12, anytime we're taking a number and we're plussing or minusing a value onto your function, what that represents, please remember, is your vertical shift. Okay, so any value being added onto your function represents your vertical shift. Now in this case, the vertical shift is a -1, which essentially is saying that your entire graph is being moved 1 unit down. Okay, so if I were to draw that, let's draw h of x and see what it would look like. This point over here has now moved 1 unit down. This point, which is at 1, has moved 1 unit down. This point has moved 1 unit down. 1 unit down, and 1 unit down, and so on. Okay, so if I were to actually redraw this, I'm just going to draw it on this side here. Not miss the points. Okay, that would be your new function. So the shape of the graph has not changed. Okay, nothing's changed in terms of your period, but what has changed is that the whole graph has been moved 1 unit down. So the question is asking us, what is the maximum value of h of x? So what's the highest point on my y-axis that we're going to be reaching? 0 is going to be your highest point. Okay, so your maximum value for this y graph function over here, for h of x, is going to be that y equals 0. Okay. And I hope everybody understands that. Your vertical shifts are the ones where if it says -1, it means -1. We move everything, we move all the points down 1 unit, okay? However, if it's a horizontal shift, if you just remember to quickly throw that in here just so we know. All right, let's say I've got a sine of theta plus 30, let's say. Okay, as soon as we're adding or subtracting a value onto your angle, that is in your horizontal shift. Now remember with that, your horizontal shift, your axis is moving underneath the graph, not the graph itself. So as a result, if it said plus 30, if you remember what happens, is it actually looks like your points are moving back 30. Okay, and as a result, everything will move minus 30 degrees to the left, and your graph will shift. Okay, if we have time, we'll give that one a try, and we'll practice a bit of it. I'm going to give you a quick break and catch your breath. I hope you guys are all working on that tan question that I asked you to have a look at. We'll go over it shortly.
Okay, guys, we're going to take a little break. The page is on fire. Hey, Monaka?
Blowing up.
Merara. Oh, because I was actually looking and I was about to say, Monaka is on the page and she's from Limpopo. And she says it is hot in Limpopo.
I think it's 33 today. Hey?
Yeah, I think they said it's highs of 34 here in Josie, guys. So let us know what the weather is looking like there. And keep cool, keep hydrated. Make sure you're very well rested to study. And yeah, pretty much that. And also Kashifa's always on the page. And she said that spring school is almost over. And she's got a little sad, crying face.
Aww.
I know, I feel exactly the same way. And also Sidonia is also pretty sad. And we were talking about there are 21 days left until finals. So it really is the final countdown. And talking about 21, this is the number that we really want to get our Facebook page to. We are 19,000, and we think that 21,000 isn't such a huge stretch.
No, it's the perfect number even.
Exactly.
The perfect age also.
That's exactly. We want to have our 21st birthday here on Mindset Learn by reaching 21,000. So get your friends to like facebook.com/learn extra to get them chatting to us. Also on Twitter @Learn Extra. What we're going to do is we're going to take a quick break, go and get yourself some water, get yourself some refreshments, and stay stuck to the couch. See you now.